Guys, today I'm going to prove to you that the derivative of sine of x is equal to cosine of x, and the derivative of cosine of x is equal to negative sine of x. Things that we're going to need to know today to be able to do that is the definition of a derivative using limits. So we'll have the limit as h approaches 0 of the difference quotient, which would be f of x plus h, minus f of x all over h. So we need to know how to use that. We're going to use the longhand method or the definition of a derivative to actually show that the derivative of sine of x is cosine of x and the derivative of cosine of x is negative sine of x. Also, there are some identities that we need to know, that we need to remember from trig, and there's two of them actually. The first one is going to be the sum identity for sine. So sine of a plus b is just going to equal sine of a cosine of b plus sine of b cosine of a. So we learned that in trig, and also we need to know the sum identity for cosine. So cosine of a plus b, which will equal just cosine of a cosine of b minus sine of a sine of b. Okay, so that's something we need to remember from trig. Something else that we need to remember from just earlier in calculus is going to be two of our limit identities that we know that will hold true, and that will be the limit as theta approaches 0, or you can use an h there, however you want to use it. We used h above, but in this case I'm going to use theta since I started with that. So the limit as theta approaches 0 of sine of some constant times theta all over that constant times theta on the bottom is going to equal just 1. Okay, that's one of our identities that we have to know. And then also the other one that we have to know is going to be the limit as theta approaches 0 of 1 minus cosine of theta is just all over theta is just going to equal 0. So there are a few things that we need to know before we start, and you need to know where they're coming from to be able to follow along as I prove that the derivative of sine of x is equal to cosine of x. So I'm going to scroll down just a little bit, so some of this is going to be cut off, but if you need to, you can pause the video and go back to see some of these identities. So here I'm going to start with our first function, which is going to be f of x equals sine of x. So you're later, as you're watching this, it's later in calculus, you know that the derivative of that is actually going to be f prime of x is equal to cosine of x. So you know the end result, or you know what it should equal once you take the derivative of this. And now I'm going to use the definition of derivative to find this. So the limit as h approaches 0 of, now we use the difference quotient, so sine of x plus h minus sine of x all over h. Okay, so now at this point I'm going to distribute, or I'm going to use our trig identity for the sum here to go to my next step. So the limit as h approaches 0 of, in this case it's going to be sine of x cosine of h plus sine of h cosine of x minus the original function, which is sine of x all over h. Okay, so sometimes kids get hung up here on knowing what to do with the next step, but I'm going to try to manipulate this problem to look like a few of our rules or our identities that we have up here at the top here. And by knowing that, I'm going to move this negative sign that's at the end up front, and as I work through it, you will start to see why. It'll start to click, or it will make sense. So I have sine of x times cosine of h. I'm going to move that minus sine of x there in the middle, and then I'm at the end I'm going to have plus sine of h cosine of x all over h. And the reason why I'm going to do this is because now you can see we can break this down back to individual fractions. So I still write the limit as h approaches well, my pen won't write here, as h approaches 0, of sine of x cosine of h all over h. I'm going to carry the sign that's between it, minus sine of x over h plus sine of h cosine of x all over h. Okay, so now at this point, once again, I've actually broke it down one step too far for it to work for us. But what do we notice in this first two terms here? What do we notice it has in common? Both of them have a sine of x in it. So with that being said, I can actually just piece these two back together, and while doing that, I'm going to factor out the sine of x. So when I factor out that sine of x, I end up with cosine of h minus 1 all over h. Alright, so we're getting close to that identity of the limit as h approaches 0 of 1 minus cosine of theta over theta to equal 0. So make sure you write your limit here. So I'm going to have the limit as h approaches 0 out front. But to make this work, we can see I'm going to need a 1 minus cosine. So what if I just factor out the negative sign? If I make that negative, that now would become a negative cosine, and that negative there would become a plus 1. So then I could rewrite that as 1 minus cosine of h. Okay? I'm going to finish out writing what's over here on the right, and let's see if we can recognize anything that's happening here. As I write this, since it is multiplication, I can actually write this as cosine of x times sine of h over h. And the reason why I do that is because I can now use the limit as h approaches 0 of sine of c of h over c of h to equal 1. So now we can kind of see where we're going with this. Let's write this to where it's easier to do the next step. So it would be the limit as h approaches 0 of negative sine of x times, in this case we're going to write it as 1 plus, or 1 minus, sorry. We want it to look like our identity, so it would be positive 1 minus cosine of h all over h. And you agree, with algebra here, with multiplication, when you're multiplying fractions, you just multiply straight across, and this negative sine of x would actually be over 1, and when you multiply them back together, it would give you the step above. So we haven't broke any algebra rules here, and then now I'm going to have plus cosine of x times sine of h over h. Now at this point, all I have to do is just evaluate the limit. So by doing that, we're just going to take this and follow each of these rules. And if you can't see it, this would actually just be the limit of, as h approaches 0, of negative sine of x, and then times the limit as h approaches 0 of 1 minus cosine of h over h, plus the limit as h approaches 0 of cosine of x times the limit as h approaches 0 of sine of h over h. So now at this point I can evaluate this. I can plug in that h to anywhere there's an h, and we can see here there with a negative sign there is no h, so I just get negative sine of x times, when I evaluate this, all of this limit, when I evaluate from what I told you earlier, all of that will just be 0. So I end up with negative sine of x times 0, plus, when I evaluate the limit as h approaches 0 of cosine of x, that's just going to be cosine of x, times the limit as h approaches 0 of sine of h over h. All of that is just going to equal 1. So I end up with times 1 right there. And then our final answer here is anything times 0 is 0. So 0 plus cosine of x times 1, which is just cosine of x. So there's where the derivative of sine of x equals cosine of x comes from. So now let's do the same process now using our identities to show that the derivative of cosine of x is equal to negative sine of x. So on this step I may not be as detailed as I was in the first step, so I may skip a few steps, but I will try to tell you as I go on what I'm skipping. So remember, we're going to find the derivative of cosine of x to equal negative sine of x. So there's our final goal. That's what we're trying to reach. So we're going to do so by using the limit process. The limit as h approaches 0 of difference quotient cosine of x plus h minus the original function, which is just cosine of x all over h. So the next thing I can do is use our identity, our sum identity, to expand that. So the limit as h approaches 0 of cosine of x cosine of h minus sine of x sine of h, all of that minus my original function, which was cosine of x. Okay, so now we have to try to see something here. We're trying to see some identities work here. So what I see is, I see there's going to be a cosine in common with these two here, and when I factor out the cosine of x, it's going to leave me with cosine of h minus 1, which we can manipulate to be the 1 minus cosine that we need. So I'm going to put the two of them together or side by side and then factor out the cosine of x. So there's a step I'm skipping, but I'm telling you what I'm doing. So take out the cosine of x, that's common in both terms. That leaves you with cosine of h minus the 1, and then at the other end of it you're going to still have the minus sine x sine h all over h. Okay, so now with this step, what do I need to do? I need to fix that so it reads 1 minus cosine. So to do so, I'm just going to make that a negative that I factor out. Instead of being a positive cosine, we factor out a negative cosine. And when I do that, I end up changing the sign of both the cosine of h and the 1. So that would actually just give me a positive 1 minus the cosine of h all over h minus. Now over here, I'm going to write this as sine of x times my sine of h over h. Okay, so now when I write this, I can break it down to the limit to each of these, and we can see that the limit of negative cosine of x, there's no h to evaluate, so that would just still be a negative cosine of x. And then this part right here, when I evaluate it, we know that it's going to equal just 0, so that would be 0. So I can make that a 0 there when I evaluate. Minus that sine of x just stays there, so that would just be minus sine of x times, we're looking at evaluating this as the limit as h approaches 0. We know that all of that will go to 1, so that would be times 1 right there. And then our final answer, when we simplify this, 0 times anything is 0, so I end up with 0 minus sine of x times 1, which is just minus sine of x.